All right, so the first thing I want you guys to do is first answer the 3 questions. Put this video on pause and see if you can answer the 3 questions based off the previous lesson. Just to see if you can get this. And then when you're finished, then press play again. All right, so hopefully you paused it and at this point you've answered the questions, because these are a good indication of whether you understand or not. So it says, which of the following points is not a point of discontinuity? So according to this, it's a square root function. We take the value that's underneath the square root function, x minus 1, and we know it has to be greater than or equal to 0. So x has to be greater than or equal to 0. So it says, which of the following points is not a point of discontinuity, which means it is included in the graph. Well, process of elimination, if x has to be greater than or equal to 1, -1 is out, -1/2 is out, 0 is out, 1/2 is out. Therefore, x equals +1 is our answer, because the graph of this starts at 1 and it goes to the right. Now for 2, what you probably want to do is you want to sketch this function first, because it'll allow you to identify which of the statements is not true. So there's 3 pieces to this. A piecewise function, there is no number of pieces that you can have, but in this particular case you have 3 pieces. So we're going to take piece 1, which is right here. The function is 2x, and I'm going from 0 to 1. Now I'm going to include 0 and 1, but because they don't have equal signs with the inequalities, I'm going to give them open circles. So if I subbed 0 into this function, I get 0. So I have 0, 0, open circle. Let's say if I sub 1/2 in, so here's 1, but if I subbed 1/2 in, 2 times 1/2 is 1, so that gives me 1 point there. If I sub 1 in, 2 times 1 gets me 2, but again, open circle. And it's a linear function, so I'm going to connect those dots. Piece number 2 is in the middle right here. It's telling us that when x is equal to 1, the y value equals 1. So at 1, 1, I get a point. There's piece number 2. Now for piece number 3, again, I have another linear function. I have a compound inequality, neither are equal, so I'm still going to sub those values in and see what I get. So when I sub 1 in, -1 plus 3 is 2. Open circle, puts me right on top. You can sub 1.5 in or just jump right to the 2. But if you sub 2 in, you get a +1. Again, open circle. So if we connect these dots here. All right, so now let's go back to the questions and see what works. So it says f of 1 does not exist. Well, if f of 1 did not exist, that means there is no closed circle at any point on 1. Well, here's 1, and you see a closed circle. So f of 1 has a value, it's equal to 1. So that does exist. So that one's okay. For b, or it does exist, sorry. So it says which of these is not true. So given that it does not exist according to the question, that one's false. So we circle that one. It says the limit as x approaches 0 from the right exists. Well, as you're coming down the blue line from the right-hand side towards 0, the value is approaching 0. So that's okay. It does exist. Let me actually get rid of this check because that's wrong. Okay. For C, the limit as x approaches 2, so here's 2, from now the left-hand side, so now we're coming down the red line, it exists. So as it's approaching 2 from the left, the value does exist, and that's equal to 1. So we're good there. For D, it says x approaches 1, just 1 in general. So that means there's no direction, which means you're coming from the left and you're coming from the right. So if you're coming from the left and you're coming from the right, here's 1, you're coming this way, and you're coming this way. Well, that value is equal to 2, so that does exist, so we're good there. And now it says the limit as x approaches 1 from no direction, which we just found, which was 2. And then f of 1, which we did in A, those do not equal each other. Well, that's also a true statement, which means A is the only answer that you would give for a statement that is not true. All right, for 3, it's saying that which of the following points of discontinuity is not removable? So remember, a non-removable would therefore be a vertical asymptote or a jump. But the only one you can really determine from a function itself, unless you have a picture, would be a vertical asymptote. Okay, so according to this, what I would suggest is break it all up. So we have x minus 1, I've got 2x minus 2's, and I have 2x minus 3's. Denominator, I have an x minus 1, x minus 2, 2x plus 1's, and 3x minus 3's. Now, in order for something to be a vertical asymptote, that means it should be left over. So let's see what cancels. The x's are gone, and x minus 1 is gone, and x minus 2 is gone, and 2x minus 3's are gone. So if it is a vertical asymptote, that means it needs to be left over. So what we have left over here, we have x plus 1, we have x plus 1, and we have x minus 3. So if I set each one of those equal to 0, I get -1, and I get a +3. And those would be your two vertical asymptotes for that. So you can have more than one. Again, we had another function where it was both of them. Both we had a whole and a vertical asymptote, but you can definitely have two vertical asymptotes for sure. All right, so when we talk continuity, a lot of the properties do apply. You can multiply, you can add or subtract, and you can divide. So I'm going to give you just a few instances of these, just so you can see combinations, and then we're going to go over something called the intermediate value theorem. All right, so it follows, we got continuous at every point in the domain. So let's just say I give you the function f of x equals x plus sine of x. Okay, well, x is continuous, that's a line. Sine of x is continuous, there's no points of discontinuity. So both of these, both are continuous. So that means f of x is continuous. All right, second one. We've got f of x, let's do this. We got 3 cosine x. So we know that cosine is continuous, and if you take a number and you multiply by a continuous function, you still get a continuous function. So a number multiplied by a continuous function is still continuous. Okay, and then with the last one, I'm going to make a fraction out of it. So if I have f of x equals x squared plus 1, and let's use, say, cosine again, over cosine x. So the numerator is continuous everywhere, the denominator is continuous everywhere, so the quotient is continuous. So both continuous, so the quotient is. So the quotient